Okay. Hey, it's Ryan Checo. My project is on current. Okay. So the definition of current is the rate at which energy flows through a circuit, and it's the measure of current is in coulombs per second, which also means ampere. So the analogy that I made for current is that let's say we have a hose with water flowing through it. So that would represent a wire with electricity with electrons moving through it. That's powered. So the wider the hose, let's say that's less resistance, right? The wider the hose, the more of electricity that can flow through it. Now, if we have a really small hose, thin hose, then not as much water is going to flow through it. If there's a kink in the hose, let's say a really high point of resistance, a kink, there's going to be no water flowing through it, or very, very little. Or if we have, now let's say we have a split path with the hose. Some of the water is going to go out through one way, some of it's going to go through the other way. But we know that the water in one path plus the water in the other path is going to equal what it was before that. So if they joined back up, it would equal the same amount of water that was in before and after. So that's going to be helpful because in current, when you have a path that splits and joins back together, it's going to equal the current's going to equal from before and after, and the current that's in the two different paths is also going to equal if you add them up together. So that's important. So the equation for current is that if you have your voltage and resistance, you can easily calculate current. It's going to be voltage divided by resistance at a point in the path. So so some extra facts about it is that when there's more paths, when there's more paths, the current increases because now, let's say there's more places where it can go, right? It's wider. It's like we have a highway. If the highway's got more lanes, there's more cars that can go in at the same time. So if we have one path versus two paths, it's gonna be double in the two paths, the current. And another thing about current is that it's always the same along one path. So no matter where you measure it, it's gonna be the same. It only changes when the path splits. The amount of paths change at a point. So let's get into the equations now. We have just showing the simple basics about current. We have one loop, 6 volts being powered into the loop, and a resistor of 6 ohms. So if we go around this whole thing, it says 1 amp. Now, why does it say 1 amp? Because if we use our equation, we have 6 volts going through this one path to this resistor, which has 6 ohms. 6 volts divided by 6 ohms is going to give us 1 amp. So now we know around the whole circuit, it's going to have 1 amp. So that's just a simple one. To go into our next one, now we have 2 amps coming out of the battery. Now the reason for this is we have the same thing, a path with 6 volts going into a resistor of 6 ohms, and another path of 6 volts going into 6 ohms. So that's 1 amp coming out of the path of B and 1 amp in the path of C. So now when they come back together, it's going to equal 2 amps because they equal. Just like when we said about the hose, when you have all this water and then it splits up, it's obviously going to have some of it in one path and some of it in the other path. It's the same thing. It's split up, and there's two paths, extra paths, so now the amperage is double. We'll get into this one afterwards.